together. So in this case, what is happening is we have been, if you recall from this sheet here, what we have is alcohol phenol. Okay, okay, the better one rather than this one, I can see this is better version. So if you look at it, what does it say here? If you react phenol with NaOH, it will produce a salt of sodium. So I can then say, based on that information, if I look at it, in this case, this will change into this Na will change, this will change to O minus and Na positive. In this case, this whole thing will change into COO minus and Na positive. In this case, this will change to OH. So in this case, it will react with O3 of them. Okay, good. One more question that I want you guys to do is question number 13, please, quickly. Okay, let's quickly have a look. So in this case, I can say, it says here, which compounds have or has 4 peaks in carbon 13 NMR spectrum. I can say for this one, this is one environment, they are both in the same environment. These two are in the same environment, and this is active in a different environment. For this one, I can say this is environment 1, 2, 3, and 4. So it will produce 4 peaks, 4 peaks. But when I look at the third one, I can see this is 1 and 1. So they're both the same environment. This is 2 and this is 2. This is the same environment. And this one and this one, they are all the same environment. So in this case, I can say the total of environments available are 3. So the question says which will have 4 peak. It's only going to be 1 and 2. So the answer is B.
Sorry, I'm late, sir.
That's fine. Got the paper in front of you. Let's do one more question from here. We are looking at question number 7 now. So on question number 7, what it says is, it says methanol shown below is heated with an acid catalyst. So you've got methanol and you have heated it with a catalyst. So when you heat it with a catalyst, it will produce alkene, and this will be elimination reaction. Now in this case, I can say there are 2 options available to me. That in this case, there are 2 options available for the elimination of water. H2O will be removed. So I can say there's a hydrogen here, there's a hydrogen here. So there are 2 possibilities. Double bond could form here and double bond can form here. So these are the 2 possibilities. Now let's see. We can see there are 4 structures given to us. 1, 2, 3, 4. This is not possible. Number 1. We can say this one is not possible 2. I can see this one is not possible 2. This is the only option that's left. But in this case, like I said, the only option where you can have a double bond is either at location 1 or location 2. But what I see here is my double bond is on the left side. So what they've done is they've flipped this molecule and then given you the option. So in this case, basically what has happened is it has resulted in this molecule, but this is the flipped version of this. They are both equal. Okay, it's just picked it up, flipped it like this, and placed it there. So they are both exactly the same. Done. Okay. What we got to do now, again, we'll start working from the last question and then we'll move backwards, because I know you guys are more fresh at the start. It's better to work on the questions from the last page first and then move backwards. So let's quickly have a look at this question. It says here you've been given three compounds called D, E, and F, and they are all isomers with a molecular formula of C5H10O. One of the compound is alicyclic. So one of the compound is your alicyclic. Means it will have a ring. It will have a ring. Now it says the student carries out test tube reactions on the compounds. The observations are shown below. I can quickly have a look at the molecular formula, and it shows me that it only has one oxygen. Only has one oxygen in it. So I can now say when you add 2,4-DNPH, there is no change. What does that confirm? This confirms that it has neither aldehyde nor ketone. So it is neither aldehyde nor ketone. Then when you add potassium dichromate acidified, then the solution changes. So it can be oxidized. It can be oxidized. And when you add bromine water, nothing happens in this case. So I can say this confirms kind of it is alcohol. For the next one, when you add 2,4-DNPH, this observation tells me that it is either aldehyde or ketone. But when you add potassium dichromate, nothing happens. So this confirms it is ketone. And no change in color means this is confirming that no double bond is present. Okay. Number one. Now it tells us a little bit more. It says for carbon 13 NMR of spectrum D, compound D has three peaks at these locations 24, 36, and 73. So what I now need to do is I need to go back to my data booklet and have a look. In this case, if I look at my data booklet here, this is carbon 13. This peak at 24 and 36. 24 and 36 is for C-C1. And there's a peak at 73. Where is that peak? 73. 73 is for C-O. C-O. Right, so there's an alcohol there as well. Plus, it does tell us something more here. What is it that it is telling us? Three peaks means what? There are three different environments. There are three different environments. If you look at the next page, the question basically asks us to identify what D, E, and F are. So it says analyze the observations and results to identify the structures of D, E, and F. So let's start. So I can start working on D because this is the all information that I have related to D, because after this everything is about compound E and compound F. So for D I can say it is compound D is alcohol. Agreed. Number two, I can say it has carbons in three different environments. Okay. Once I've done this, now I need to start working out what the structure of this will look like. How many, what's the molecular formula? C5, H10, and O. So if I look at it, I can say 1, 2, 3, 4, 5. If I put my OH here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. What I can see here is I'll have one peak due to this. I'll have one peak due to this. I'll have, so this is environment 2, environment 2, environment 3, and environment 3. So it will produce 3 peaks. Three peaks. But there is a small problem here, because if I count the number of hydrogens, how many hydrogens do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. But the formula for this one is now C6, not C6, C5, H12 and O. That's the formula. Are the two formulas same? They're not the same. So what I need to do is I need to modify it. So I can say this can't be the structure. Can't be the structure. What will I need to do now? I'll have to modify it. So if I go back, it tells me something. So before I go back and have a look, what's the difference between them two? The difference is of two hydrogens. Difference is of two hydrogens. So if I go back and look here, it says one of the compound is alicyclic. So this means if I make it a ring, then I can take two hydrogens away. So I can say this can be changed into now how many hydrogens will be there? 1, 2, 1, 2, 1, 2, 1, 2, and 1. If I put these all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's 10. I can see now there will be one peak due to this, one peak will be due to these, and one peak will be due to these. So I can say for this one, it will produce 3 peaks. Number 1. And number 2, the molecular formula is C5H10. So this is the correct version. Okay, this is my answer 4. So this is my structure D.
Unit A.
Now let's move on to compound E. Again, compound E has the same molecular formula C5H10O. Let's see what data is given to us for it. Uzair, first understand everything and I'll give you time to copy later. What we have here is for compound E, I see there are 2 peaks in H and MR. There are 2 peaks. 2 peaks means what does that tell us? That tells me that the hydrogens are in 2 different environments. So I can say from this graph, I can then say hydrogens are in 2 different environments. H atoms are in 2 different environments. Then I can see there are 2 peaks. One peak is at 1 point, let's say 1, and the other peak is at 2.4. I'll go back and have a look at my data booklet. I can see at 2.1, sorry, at 1.1, what do I have? This is due to R dash CH. This is due to hydrogen bonded to carbon atoms. So C is bonded to H, and then I have something called R here. At 2.4, there's something due to these hydrogens. The hydrogens which are bonded to carbon double bond with oxygen. So I can then say this one is for this. Are we happy with that way? Now, if I look at it carefully, how many environments have I got already? I've got 2 different environments, right? Now I need to see the splitting pattern. What does this splitting pattern says? This one is quartet, right? So this means the next carbon atom is a quartet. Yeah. So 1, 2, 3 should have how many hydrogens on it?
3.
So we can say this one, next C atom must have 3 H.
You have to specify that they're symmetrical.
What do you mean symmetrical?
Or aren't they supposed to be like in this? Not symmetrical. Sorry, like in the same
They'll be
environment.
yeah, but once you have done that, that means they are in the same environment. If they were in different environment, then you will not have a quartet. You'll have something more, right? When it comes to the 1.1 peak, how many peaks do I have here? The splitting pattern is 3. So this means in this case, next Ca atom has 2 hydrogens. Are we happy with that bit? So I can modify this section into, what am I doing here? I made a small mistake here. So this is written like C double bond O and CH. I wrote it a little bit differently. So it should be CH. It will get modified into, there is a hydrogen here. Next carbon atom must have how many hydrogens on it? Are we happy with that? If you have 3 here, then this will produce a doublet. No, sorry, doublet, triplet, quartet, n plus 1 rule. So if it is 3 here, then it will produce a quartet, right? Now, in this case, the next carbon atom needs to have how many hydrogens? 2. And this is the case. If you look at it, so I can say the next carbon atom will have, now it is a symmetrical molecule. So if I combine these two things together, I'll have C double bond O dash, and then on the left side also I'll have the same thing. We then have to check for our requirement, do I have the same molecular formula? So I can then say there will be 1 due to these two and them two. Agreed? Yeah. And these two will have an other environment. These two will produce triplet. These ones will produce quartet. Does that make sense? Are we happy with that bit? Mohan? Yeah. All good so far? Okay. Now let's move on to the next. Before I move on to the next, I need to check what's the molecular formula for this. 1, 2, 3, 4, 5. So C5H, how many? 3, add 2, 5, add 5, 10. And oh, this is fine, this is fine. I'm good with that. Now we need to look at compound F. Compound F. Compound F is, again, I know it is a ketone. I already know it's a ketone from the previous result. This one was also ketone. Now if I look at the next one, how many peaks do I have here? 1, 2, 3. I can say 3 peaks. Therefore, hydrogen atoms are in 3 environments. They are in 3 environments. Once I've identified this, the next bit that I need to check now is, where are these peaks at? First peak is at 1.1, second peak is at 2.1, and the third peak is at, let's say, 2.6. So the peak at 1.1 is doublet. Peak at 2.1 is singlet. So that's not shown. So the peak, we've got 3 peaks, one at 1.1, one at 2.1, and one at 2.6. So the first one, which is at 1.1, is doublet. The one that is at 2.1, it is singlet. And the one that is at 2.6, that one is multiplet. Now I can extract some information from here. Now I can say doublet means next C atom has 1 carbon hydrogen. Okay, this is singlet. This means next C atom has no H on it. This is multiplet, and if I look at it carefully, how many, the rule is n plus 1, so how many peaks do I have? 1, 2, 3, 4, 5, 6, 7. So this means there are 6 H on it. Should be capital H. Capital H. Done. Now I can go to my data booklet and have a look. The peak at 1.1 is due to this. Is due to this, and it tells me that it needs to have only one hydrogen on the next carbon atom. So this one is due to C, R, and H, but it tells me the next carbon atom should have only one hydrogen. Okay, let's put it this way. You can say something like this. Can have only one hydrogen. What will I talk about when I look at this one? This tells me that the next carbon atom has no hydrogen. So if I look at the peak at 2.1, the peak at 2.1 is due to this section. I can then say I have C double bond O dash C, and I've got a hydrogen here. This one says next carbon atom has 6 hydrogens on it. Next C atom has 6 hydrogens. Now I need to modify this. Could be atoms, right? Because one carbon can only have up to 4 bonds. You can't have 6 hydrogens on it. So you have basically there are 2 carbons next to this. So it will be something like C, CH3 and CH3. Here you'll have H and something. Are we happy with this bit so far? So now I need to combine all of these. So I know what was my molecular formula. My molecular formula is C5H10. Now if you look at it carefully, what will these two do? These both will produce singlet. This one will produce multiplet. So this basically has now come here. This top section where it was a no, this is doublet, not this part. This section has been brought here. So if I combine them two together, singlet, multiplet, this is also, what is this?
That's the doublet.
Sorry,
Isn't that the doublet?
this one is the, why would it be
Oh,
doublet?
sorry. Oh, no, that's a singlet.
So I need to come up with a structure. So if I look at it, what I can do is I know this section and I need a singlet. So in this case, this will not be a singlet. This will be a, what would it be?
Maybe
A doublet. That's why I was kind of confused. So this is doublet. And this is my singlet. Once I've done this part, I need to combine them two together because this meets my requirement. So this has already been brought here because this section will produce doublet. So now what I can do in this case is I'll start with my molecule and I need to start with C double bond O dash CH3. That's my singlet peak. Then I need to have C dash H. Now this one needs to be 6 peaks. So I can say here I'll have CH3, here I'll have CH3. And now if you look at it, this one will be my singlet. This one will be my multiplet. And these two will be singlet.
there's two singlets
Which ones?
on both sides.
So what will it be?
The doublet.
Why will it be doublet? Because the rule is n plus 1. So in this case, here you have one hydrogen, so it will be doublet. So do I have everything that I need to in my molecule? Got singlet, got doublet, and I also have a multiplet. Okay, so I can then say this, and I can go over it once more. We said for this molecule, it is a ketone. We need to have 3 peaks because there are 3 different environments. So that's what we can extract from 3 peaks. So hydrogen atoms are in 3 different. I wrote down the locations where the peaks are, and I noted at this location is a doublet, at this location is a singlet, at this location is a multiplet. Then I looked at my data booklet and I found out, before I looked at my data booklet, I said here doublet means next carbon atom has to have 1 hydrogen. Singlet means next carbon atom has to have no hydrogen on it. 2.6 multiplet means next carbon atom or atoms they must have 6 hydrogens on them. We can modify on them because it's a multiplet and it was 7 peaks when I looked at the HNMR. Then I looked at my data booklet, and it tells me this is for the carbon chain. When you have the peak at 1.1, this is for the carbon chain section. Peak at 2.1 is due to C double bond O. And because it has to be singlet, so there's no hydrogens on the next carbon atom. So I said it's going to be something like that. And for the last one, says it has to be multiplet and you need to have 6 hydrogens in the same environment on the next carbon atoms. So I said it will look something like this, right? And then once I started analyzing this, I can see here these two will produce doublet, this will be multiplet, this will be my singlet. So if I combine them, I can come up with this structure. This is the structure of the ketone, which will produce 3 peaks, with one being singlet, one being multiplet, and one being doublet. Are we happy with that bit? Okay. Yeah, okay. Let's quickly move on to the next question. So, people taking class online, are we all happy with the answer?
The code is 5718, right?
5017. Next question here. What is happening in this case? It says this question is about reactions of phenol. Before you guys arrived, we did a question on this. What is happening here? You react with NaOH, and when you react with NaOH, it will form a salt. Then you add carbon dioxide, and it forms this molecule. Then you add HCl, and it changes into this. Okay, so now let's quickly have a look. It says complete the mechanism below to show below for stage 1 and stage 2. Show curly arrows, the structure of the intermediate and the missing formulae on the dotted lines. What am I doing here? Am I reacting it with this? I know this has formed minus, so this means it has got extra electron. Agreed? So it will accept electrons from this bond, and then this lone pair will be given to this. Are we happy with that bit? Yeah. As a result of this, you'll have this plus H2. Once you've got this, then the next bit that you need to look at is now the next bit is about the reaction of ring. It's about the reaction of ring. So what will happen in this case? I can see this is delta minus, this is delta minus, this is delta plus, so it is electron deficient. So what will happen? It can accept electrons from the ring. These electrons will go to this oxygen. Okay, as a result of this will then change into happy with that. This will be negative because it has accepted electrons. What will then happen? Now we need to restore the ring. The next bit will be, this will then be given back to the ring. You will have this plus H positive. Done.
What's the mechanism called?
This one, this is the, so what is this acting as? Electrophile. And in place of hydrogen, this has now been attached. So it will be electrophilic substitution. Electrophilic substitution. Okay. Next part. Here it says now what are the roles of OH minus and CO2 in the mechanism. So I can see if I go back, what did OH do? OH basically accepted a proton, so it is acting as an acid. OH accepted, no, if it accepts a proton, then it acts as a base. If it donates a proton, then it acts as an acid, so it is acting as a base. And then CO2, what did it do? It accepted a lone pair. It accepted a lone pair, so it is acting as a 1O. Would it be electrophile? Because it's electrophilic substitution reaction. It will be like electrophile. Next question says two molecules of salicylic acid can react together in the presence of an acid catalyst to form compound B. So we need to now recall what is salicylic acid. So if you go back, it tells you this is your salicylic acid. Okay, so if you go back to the previous page, this was our product, and you can see here it has alcohol group and it also has acid group. So if you have two of them, then they will react to form ester linkage. They react together to form ester linkage. So it now says two molecules of this can react together in the presence of acid catalyst. The compound B has 3 rings and a molecular formula of C14H8O4. Write the equation for this reaction showing the structure of organic compound. I'll copy the structure first. Just a ring. Here I have OH. Here I have COOH. Okay, I can have another of this, but when I'm writing another one, I'm not going to write it like this. I flip it just to make my life more easier. So I'll say at this location I have COOH. This location I have H. Agreed? Now, when they will combine together, what will they do? You'll have first one at this location. You will now have O dash C double bond O dash. You'll have same thing here, but in the reverse order. C double bond O dash O. Agreed? Now this has to be bonded to the ring. So I can then say does that make sense? Now, if you look at it, one water molecule will be removed from here, one water molecule will be removed from here. So I'd say it will be plus 2H2. If you recall, this is something that's called ester linkage. Done. Next question. Now it says the student reacts phenol with nitric acid and sulfuric acid at 100 degrees Celsius to form impure crystals of an organic compound C. The student purifies the crystals by recrystallization. Describe how the student could recrystallize the impure crystals to obtain a pure crystal. So what happens in recrystallization? First of all, you will have to we can say dissolve in solvent, but has to be hot solvent. Okay, then what would you do? What will you do then? Then you will cool and filter. You leave it to dry. So if you look at the answer here, it is telling you that impurities are soluble in cold water as well. What are we assuming here? The impurities are soluble in cold water as well. We can say our assumption is impurities are soluble in cold. What will happen when you filter it? The acid is not soluble in cold water, so it will be separated as residue, but the impurities will dissolve in liquid and they will be removed. Okay, now next question before I start working on it, let's see. The question says analyze all the information to suggest the structure of C. So we need to determine the structure of C based on this data. Again, one of the very important questions. So what I see here is I'm not going to look at this section first. If I look at it carefully, they've given me some information. I can make use of this information to work out empirical formula. I've then been given the MR, right? Because it says molecular ion peak is at this. I can use this to work out molecular formula. Okay. Then I can use this to determine structure. So if I work out the empirical formula, my empirical formula, I'm not going to go into the details of that. You know how to work out. You can make a table and you will have to add 4 things in it. What are those 4 things? Carbon, hydrogen, nitrogen, and oxygen. You'll work out the first, you'll say mass, you will then find the moles, then you'll find the simplest ratio. And from here, what is happening is we figure out that our empirical formula turns out to be is C6H3 N3 and O7. N3 and O7. Now, what is the MR of this? The MR of this is 229. So I can then say my molecular formula is also C6H3N3O7. Are we happy so far? So what I've done is I use this information. I worked out the empirical formula because the empirical formula and the molecular ion peak has got the same mass. Therefore, they both have the same formula. So molecular formula is same as empirical formula. Now I need to determine the structure. But before I determine the structure, what did they do? You need to recall. If I go back, they've got phenol and they're reacting it with H2SO4 and HNO3. This will produce, remember phenol is this and OH here. it will do substitution at locations either 2, 4, and 6 or 1, 3, and 5. They've given us some information at the bottom. So it will change into something here. It will be OH. I'll have NO2 will get attached at some locations. Do we agree that NO2 will get attached at some location? Now, if you look at the bottom at this section, it tells you if you have phenol, that it will direct substitution at 2 and 4. It will direct substitution at 2 and 4. So this means I can say if it does that, 2 and 4 will be NO2 here, NO2 here. Do we agree with that bit? Okay, now we need to check, is this what we have in real life, or like from the data that we have? So it tells me here for the carbon 13 NMR, I've got 4 environments. Does that make sense? 1, 2, 3, 4. So I've got 4 different environments for carbon atoms. This means my carbon atoms must have 4 different environments. So I can then say OH here. How many environments do I have now? 1, 2, 3, and 4. There are 4 environments at the moment as well. If I use this data, being this, if it directs at this location and at this location, how many environments will I have now? 1, 2, 3, 4, 5, 6. 6 environments. So we can't have 6 environments. We need to change it to 4 environments. So if I start numbering from here, this is my number 2. But if I start from the left side, there's a possibility that this will be number 2 as well. Agreed? Now if I check the number of environments, how many environments do I have? 1, 2, 3, and 4. So my structure is, so you'll have to remember when you start numbering 1, 2, 3, 4. So it is 2 and 4. But if I start from the left side, then 2 is here as well. I can have substitution at this location. Done? Has anyone got any questions so far? If not, then we move. Go ahead. Go ahead.
I just want to say, when they give you the MR and the percentage composition by mass,
Yes.
why do you have to work out the empirical formula? Because you can just work out the molecular formula.
Okay. Sometimes you will have, for example, let's say you've got CH4, right? Not CH4. I'm going to say C2H4, C3H6, and then CH2. This is my empirical formula. This is my molecular formula. So to go from here to here, what will I need? I will need MR. Are you with me on this bit, Sana? So empirical formula and molecular formula will not always be the same. In this case, it has turned out to be the same. Because when you divide the mass MR, in this case, what do I do? I can say the MR will be given to you in this case as, so if I do 12 times 3, 36 plus 6, here they'll give you 42. This one has MR of 14. So this was not given to us. We worked out this from empirical formula, but we were given the MR. So what will I do? I'll do 42 divided by 14, and this gives me 3. So what will I now do is, this was C1H2. I'll multiply this by 3. I'll multiply this by 3, and it'll change my formula to C3H6. Are you with me on that bit now?
Yes, I know that, but what I was basically just trying to say is that when I was working it out, I just worked out the molecular formula
Straight
and
away.
without the empirical formula. Yeah.
But what I'm trying to say is, in exam, what if they give you something like this? What would you do that in that case then? What if in your exam the question doesn't have the same MR for the molecular formula and the empirical formula? What would you do in that case then? Luckily, in this case, our MR of empirical formula is same as the MR of the molecular ion peak, and that's how I know that this is same. Are you with me on that bit? How did you work out the molecular formula straight away?
I just did, like for carbon, I just did 0.3144 times the molecular ion peak, which is 72. Then I just did 72 divided by 12 because the carbon is 12, so and then I just got 6.
That's fine. That's the same thing. So basically, you have to make use of this number 229. Without making use of this number, you can't work out the. So if they don't give you these percentages, you can't work out the molecular formula. You need them. What I did is I made use of these percentages. I figured out the empirical formula and then I used the molecular formula. What you have done is correct as well. Basically, what you've done is exactly the same thing that I've done. You said 31% of this mass is carbon. Is that what you've done?
Yeah.
And then you said 1.31% of this mass is hydrogen. Then 18.34% of this mass is nitrogen. And then you said 48.91% of this mass is your oxygen. That's absolutely fine as well. Okay, so
Okay.
that method is fine as well. And the method that I've shown you, they're both fine. Now let's move on to the next question here. Question number 19. I put star here because I didn't know the name of this compound myself. I worked it out while I was preparing for you guys today. Question number 19. I'll just give you the name here. So if you look at it, I can draw it out and I'll say it will be 1. So I've got 1, 2, 3. And here you have double bond. Here you have double bond. It is H. Is that what we've got? Did I miss out something? How am I going to name it? I can start numbering it. And if I number it, what will I do? Agreed? Because this is my functional group. Then I can say it will be 3-methyl 1, 2, 3, 4. So it's going to be but 2 and enol. This is something additional that you have to keep in mind. Okay, so if it has a double bond, then you have enol rather than just null.
So we do dimethyl.
Why dimethyl? You have to go for the longest chain. So this is part of the longest chain. Okay, so for the third one, you have a CH3. Next question says, complete the flow chart below for the synthesis of two compounds starting from prenyl. So you've got prenyl, you're doing NaBH4. What is NaBH4? This is my reducing agent. So reduction will take place. And if reduction takes place, then this will change into, if I do oxidation, then aldehyde will change into carboxylic acid. In this case, it will change into alcohol. So I can draw this. It will be C dash dash double bond. Here you have CH3. Here you have CH3 double bond C dash H dash C and H. Okay. Now, what is happening on the next stage? They've changed this one into something else. What is that something else? if you look at this section at the bottom, I've got here, this is my ester linkage. So this means this is my alcohol. If I go backwards here, the reagent will be alcohol. How many carbons are in this alcohol? 1, 2, 3. So it will be, which alcohol will it be? No, it can't be propanol because the OH is on the second one. So it will be propane 2O. So it will be CH3 C dash OH dash H dash CH3. That's my reagent. Now if I go backwards, then this has to change into carboxylic acid. Otherwise you can't form the ester. So if I change this into carboxylic acid, all I need to do, yeah, so I can use Cr2O7. What would it be? 1 plus or 2 minus? 2 minus, because K is K2Cr2O7. So it will be 2 plus, and this has to be acidified. This is acidified, and this section will change into, what will it change into? If I look at the top section, it makes my life a bit more easier. This section will change into carboxylic acid. So it will change into CH3, CH3, double bond C dash H dash C, double bond O dash OH. Okay. Now, if I look at this section, I can also go backwards rather than coming forward, because again, I see here, this is something, again, what do I have here? This is my, no, this is my ester linkage. This is my ester linkage. And if I look at it, if I break it from here, this side is my carboxylic acid, and it contains only how many carbon atoms? 2. So the reagent will be CH3COOH. But if I look at the left side molecule, does it contain any double bond now? No. It doesn't contain any double bond. So what I now need to do is I need to get rid of this double bond and change it to a single bond. So when I do that, it will change into, yes, C dash CH3 CH3 H dash C dash H dash H dash C dash H dash H dash OH. Now in this case, the reagent will be H2 in the presence of nickel catalyst. This was easy to work out because I knew the condition. Okay, here I didn't know the condition, so I did backwards rather than going forward. Let's turn it over to the next page. Now I did a little bit of working on this question beforehand. Now it's an important question. So what is happening in this case is it says a student intends to synthesize compound A using two-stage route below. So you've been given benzene, it has benzene, it's chloromethyl benzene. What has happened, this has changed into an intermediate first, and then this intermediate changes into this. So if you look carefully between these two sides, I can see my product has one more carbon atom. Does that make sense? It has one more carbon atom, and that's only possible if I make it react with cyanide. If I don't make it react with cyanide, then it's not going to work for. So in the first place, what will I do? Stage 1 will be, again, I can make use of this sheet. I've got here haloalkane. If I react it with sodium cyanide, but it has to be ethanolic, it will change into nitrite. So for stage 1, I can say it will be ethanolic KC. That's my reagent. And what will be the intermediate? The intermediate will be Cl will get replaced by Cn. So I can say it will then become is my nitrile. Now for stage 2, what I'll do is I'll have to use hydrolysis. And if you are doing hydrolysis of nitrile, again, if you look at this, it tells you if you carry out hydrolysis of nitrile, it will change into carboxylic acid. For that, you use H2O in the presence of H plus conditions, which is HCl, and you will heat. So the reagents will be H2O in the presence of HCl, plus you'll have to heat. If you do that, it will then change into carboxylic acid. So this will then change into what else will be produced? Now look, I'm using acid conditions and this nitrogen has been removed. So when you, in this case, it will produce ammonia, but because you're using acid conditions, ammonia will react with HCl and will produce NH4Cl. So I've done what is needed for stage 1, what is needed for stage 2, and I've also shown my intermediate. Now it says plan a two-stage synthesis to prepare 5.44 grams. We've been given a condition for this, and plus it says the yield of the compound A from chloromethylbenzene is 25%. So I'll go back to my equation and I see 1 mole will produce 1 mole. Does that make sense? So in other words, I can say, bringing this down, I can say R1 changes into compound A. In terms of mole, this is 1, this will produce 1. Does that make sense? That's based on equation. But the question tells us the yield is only 25%. So what I need to do, I'll multiply this by 0.25. So if I want to work out the mass here, what will I do? I can multiply it by its MR, which is 126.5. So if I have 126.5 grams, I can multiply this by its MR. This is 136. It will give me an answer of 136 times 0.25. 34 grams. Now remember, this is based on equation. Are we happy with that bit? Now what we need to look at is we don't have 126.5 grams of my R1. I only have 5.44 grams. This will be X grams. This will be, okay, no, sorry. This is the other way around, right? Because we need to prepare this much. So this is, we need to prepare this as 5.44 grams. This will be X grams. Now you can cross multiply and equate and solve, and you'll end up with the answer. So 126.5 times by 5.44 equals 34 times X. Divide both sides by 34 and 34. We'll end up with a value of X being equal to, has anyone got an answer? 20.24 grams. Again, important question, but any question like this that appears in exam, make sure first thing is you check how is my reactant related to my product. And in this case, the carbon chain was increasing by 1. If the carbon chain increases by 1, you have to make it react with cyanide. That's the only way to increase carbon chain by 1. Done? Can I move on? Okay. Now let's quickly have a look at question number 18. So on this question, you'll have to memorize one thing. And if you would not know this, you will not be able to answer this question at all. This is the structure of alpha amino acids. This is the requirement that you must know. So here what is happening is, say this question is about organic acids, and they've given us 4 different acids, but they've not given us the whole structure. All they're telling us is R group for each one of these. Let's quickly write down the answer for the first one. You just have to memorize this. It says, what do we mean by word optical isomerism? Let's write down non-superimposable mirror images about a chiral cell. It says draw 3D diagram to show optical isomers of alanine. So now see, like I said to you, I can't do this without knowing this structure. So which one is alanine? In case of alanine, R will change to CH3. So I can then say it will become C dash CH3. This location I can have COOH. Here I can have H, and this location I can have NH2. I'll have to put the mirror line, and the other one will be C. The top is going to be the same. This one will appear on the other end, so it will be COOH, have H, and then NH2. Next question says, how many optical isomers does threonine have? Optical isomers. So I'll have to check, or I'll say identify chiral carbons. I'll draw the structure before I work out the answer. So this time it is about threonine. What is threonine? It is CH3, CH, and OH. So you can say CH3 dash C dash H dash OH dash. I can copy the remaining structure from here. 1H2 COOH and H. So I've got one chiral carbon here, and I also have another chiral carbon here. So in total I'll have, how many structures will I have? 4 different structures. So I can say the answer is 4 for this question. Moving forward, now what we have here is this. It says complete the flow chart to complete the flow chart for 2 synthetic routes to the amino acid valine. What is valine? So if I go back and have a look, it is C-H. Here I have CH3, here I have CH3, then I have C, here COOH, NH2, and H. Okay, that's what we have, CH3, CH, and CH3, O2, CH, that's fine. This is what I have. So what we are doing here is we start with the ester. We've started with the, yes.
Isn't the carboxylic group supposed to be on the opposite end of the amine group?
No,
of this?
they can be anywhere because these are all single bonds. Single bonds, they have free rotation.
Oh,
Okay. So we can now say we started with ester. So if we start with ester, they've got something here. What is this? This is my C acid. So from ester to carboxylic acid, what will I need to do? I'll have to carry out hydrolysis. I'll have to carry out hydrolysis. So I can say it will be H2O in the presence of H positive. Now, I need to draw the structures here as well. So what will it look like at the top? This is C7H14O3. Part of the structure has already been drawn for you below because this is the acid part. We have to add only the alcohol part. So if I look at it, I can draw the same thing again. This here I have HO. Here I'll have C double bond O dash O dash. How many carbons do I need to add now? It is C5 now, so 2 more carbons. So it's going to be 1 and 2. I can have okay. Done. Now this is one method. In this case, I've got acyl fluoride. And in this case, what I did is I've converted this acyl fluoride into this. There's only one thing. If I want to copy the same thing, I can do this will be HO double bond O. At this location, it will be Cl. Okay, and I can do this and that. Now, what are the conditions that you use for this? If you go back here, acyl fluorides are here. If I want to go back to carboxylic acid, all I have to do is add water to them. Add water. Now, if I look at this and this, they both have only one difference. And the difference here is this OH, one hydrogen has been removed and one oxygen has been removed. So what did I do? I've converted this into haloalkane. Alcohol has been converted into haloalkane. How do I do that? Alcohol into haloalkane. It tells you here. Alcohol back to haloalkane. What do you do? Sodium halide reacting with H2SO and H2SO. Acidified condition in the presence of sodium halide. So I can say here I'll have which halide will I have? Na, Br, and H2SO4. And the only thing that will happen in this case will be this OH will get replaced by Br. Now what has happened, if you look at it carefully, everything is same, only this Br now has been converted into NH2. So it's a primary amine now. It's a primary amine, and for that we use excess NH3. Excess NH3. But I've missed one thing. Can anyone tell me what is it that I need to add in addition to this? Because we've got haloalkane.
missing the bromine.
No. If I now this could be aqueous. If it is aqueous, then it will produce alcohol here. We don't want alcohol to be produced because haloalkanes they react with water. So it has to be ethanolic. Uzair, I've asked you this question many times. Yes, Mr. Ridwan.
So how could an alcohol be formed?
How can
An alcohol be formed?
from if you use aqueous conditions here, then this will change into OH.
I thought it would just turn into amine.
No. So remember one thing. So that's why we use ethanolic conditions with haloalkanes always, because if you add aqueous conditions, then this can also change into OH group, and we don't want that to happen. We want primary amine to be produced, and this is excess is being used because primary condition to ensure primary amine is the major product. Because remember, it will have a lone pair, and this molecule can act as a nucleophile and can then attack again and produce secondary amine. It will produce tertiary amine, and we don't want that to happen, and that's why we are saying we will use excess of this. Done. Okay. Next question here. Now they given us a substance called ibuprofen. We all take them as painkillers, and it says what is the molecular formula of ibuprofen? So you just count how many carbons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So C13. How many hydrogens are there? 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add 3, 15, and 1, 16. Did I miss something? 3, 3, 1, 2, and 1, 1, 1, 1, 3, 1, and 1. How many are there in total? 17, 4, 18. Am I right? I believe so, because 3 add 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 add 3 is 18. And I've got 2 oxygen, so it's going to be O2. Next question says, on one ibuprofen tablet contains 400 milligrams of ibuprofen. So I can't use mass in this unit. It has to be converted. So 400 times 10 to the power of minus 3 grams. So it's calculate the number of ibuprofen molecules in one ibuprofen tablet. So molecules means, this means moles times 6.02 times 10 to the power of 23. That's what I've been asked to work out. So I'll have to work out the mole first. So moles will be equal to 400 times 10 to the power of minus 3 divided by 206, because I worked out already. So while I was preparing for you guys, the MR of this molecule is 206. So if you divide it by 206, you'll get this. Now, if you divide them, you'll end up with 1.94 times 10 to the power of minus 3. Put this value here, and you'll end up with the answer, which will be 1.17 times 10 to the power of 21. Done, Mohan? Now, next question. I put star on this one as well, right? It says tablets based on ibuprofen and lysine are now available from pharmacies. If you go back and have a look, my ibuprofen has, this is my carboxylic acid group. Okay, So ibuprofen contains, this one is carboxylic acid, lysine has carboxylic acid plus NH2 group. So I can now say when these two will come together, what will happen? This and this will react to form a salt. So they now you be these days we have got tablets which are based on ibuprofen and lysine, and they are available from pharmacies. These tablets are claimed to act faster than ibuprofen by being absorbed in the body more quickly than ibuprofen. So more being absorbed more quickly means what? They are more soluble. They're more soluble. Now it says one type of these tablets contain a salt of ibuprofen and the amino acid lysine, which is this. Lysine has R of this in a 1:1 molar ratio. Suggest the structure of each ion in this lysine salt of ibuprofen, including the position of any charges. So if I go back and have a look at the ibuprofen, what will it do? It will release H plus ion. It will release H plus ion, so it will become negatively charged ion. So for the negatively charged ion, I'll say this acid, ibuprofen, will come down here because it will lose H plus. And in this case, I can then say, what will it become like? So it starts with, then again this, and that. I've got from here this. Oh, okay. And then I have got this is my acid. So in case of acid, I know it is C dash NH2 COOH. Here I have H. This location, it says it will be CH2 all 4 and NH2. But because it will form a positive ion, because it has these groups, they can accept proton. But they said the molar ratio is 1:1. So what will I do in this case? I can then say this one of these will change into NH3. Yes.
Why does it say CH4 on the left side?
Okay. CH. This is CH2 whole 4 because that's what we've been given R as. Look.
Yeah, no, it's just like there was nothing in front of
Okay.
it.
Sorry. Done. Next question says suggest why tablets based on a salt of ibuprofen should act faster in the body than ibuprofen. I just gave you the answer because they are more soluble. So the answer was already given. They're more soluble. Let's quickly look at question number 17. Question number 17 says this question is about haloalkanes and polymers. Freon 13 is a CFC with the molecular formula of CClF3. In the upper atmosphere, the presence of freon 13 can lead to ozone depletion. Explain with the aid of equations how freon 13 can lead to this ozone depletion. Use dots to show the position of unpaired electrons. What will happen in this case is Cl dot radicals will be produced. Radicals are produced in the presence of UV. Then what will happen? The Cl dot radical will react with ozone, producing ClO radical plus O2. Then this ClO radical will react with oxygen. It should be O3 here as well. Then it will produce Cl radical plus 2O2. If you look at it, what has happened? This is again restored therefore acts as a catalyst. Next question says, an oligomer is a polymer with a low molecular mass and a small number of repeat units. An oligomer made from 2-chloro-1,2-trifluoroethene is used as lubricant. Draw the repeat unit of this oligomer. So what will happen in this case is it says ethene means it has 2 carbons. Then it says 1,1,2 trifluoro. So 1,1, this is fluoro, 1,1,2, and then on the second one there is a chloro as well. So this and this and this is my repeating unit. So it says now the boiling point can be increased. Now remember, these are molecular substances. So increasing the number of repeat units, what will they do? They will increase IMF between.
Wouldn't you have to put the N on the repeat unit?
No, because it just says here draw repeat unit of this polymer. So they didn't say polymer, right? So if you put N, then you're saying this is repeating N times. Okay, so that would be classed as a polymer then.
I mean, it says at the top it's a polymer.
Yeah, it is a polymer, but we are showing it by extending its chain on both sides. So this is the repeat unit. Now, what will happen in this case is it says explain this statement. How am I going to explain it? I'm going to say increases intermolecular forces between molecules, right? How? Because there will be more surface area, therefore greater amount of contact points. Next page. The polymer can be made from the monomers 1,4-diaminobutane. Draw the structures of these monomers and one repeat unit of the polymer. So 1,4-diaminobutane, it will be butane 1, 2, 3, 4 carbons. It says 1 and 4 has NH2. So here you have H2N, here you have NH2, and that. Then it says benzene 1,4-diacetyl chloride. You have to draw one repeat unit. It will form amide linkage this time, remember. So N dash H, this will go in this direction, dash. Done. Now my suggestion to all of you is make sure you first look at the entire paper and then start working on the questions. Always do the questions first, which seem easier to you and you are confident with, and then come back to the questions which you find which look or appear more difficult to you. Because on this paper, the first question and started structured question was a bit different. I don't see that type of question coming in front of us while we are learning the spec. So it's a bit different from, you'll see now. Let's have a look. So this time what is happening is, first part is easy. It says but1-ene has this formula and but1,3-diene has this, are unsaturated compounds used to make many organic products. But1-ene and the second compound have sigma and pi bonds. Explain what is meant by the term sigma bond and pi bond. Now you have to remember, sigma bond is linear overlap of this is linear overlap of orbitals. Could be S or P, just linear. Pi bond is sideways overlap of P orbitals. That is buta-1,3-diene. Buta-1,3-diene means 1, 2, 3, 4. Double bond here, double bond. Agreed? I can then put hydrogen, hydrogen, 4 bonds, hydrogen, hydrogen, 4 bonds, hydrogen. So this is my structure. Now the first bond is always the sigma bond. How many bonds do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total I have 9 sigma bonds. How many pi bonds are there? Just 2, because the second bond of the double bond is the pi bond. We've been given alkene here, and what happens in this case is we are making it react with hydrogen bromide. So if you make it react with hydrogen bromide, we have two options available. You can say we will have H here and Br. Option 2 will be H here and Br here. Okay. Now, in case of the red one, the double carbocation will be here. In case of the blue one, the carbocation will be this one. Which one is more stable carbocation? The red one or the blue one?
The red one.
Why is the red one more stable?
Because it has the BR.
Alkyl group. No, it has alkyl group.
Oh.
Br will get attached later. So the major product will be one with more stable carbocation. Which is outline the reaction mechanism. In this case, what I'll do is I can say we've got H, Br dash H. This is delta plus, this is delta minus. Electrons will travel from here to this. These electrons will then be given to this. Why am I doing? Why did I do delta plus here? It's delta minus. As a result of this, you will then have, but remember it says it has to be for the major product. So I'll then draw C dash C dash 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 hydrogen. I can draw this should be here. This is not going to be there. It will just be a positive here. Here you'll have hydrogen, hydrogen. I can write down here C2H5 and I'm going to write down H. Now this is my secondary carbocation. Why is it secondary carbocation? Because I've got C2H5 here and I've got C3. So this is my secondary carbocation. Then what will happen? Br minus. These electrons will travel to this side, and as a result of this, you'll then have C3 dash C dash H dash BRH. Here you'll have C dash C. Okay. Done. Says explain why one organic product is formed in much greater quantity than the other organic product. I already gave you the answer. There's much greater quantity because it involves secondary carbocation. I need to say carbocation, more stable. Okay, I put star here, right? It's all the one marker, but it's an important question. Here it says now, how many saturated organic products could be present in this mixture? We already know there'll be a minor product and a major product. But for the major product, if you look at this carefully, this one is chiral carbon 2 because it has hydrogen, bromine, here C2H5, here CH3. So if it is chiral carbon, if it contains chiral carbon, then it will have two isomers for that. So in total, I will have how many products? Three. Three, because one, two, major and minor, but major has two isomers. I can say it will be three products because there is a minor plus major, but major has optical isomers. That's why it will have three products. Zaid, are you with me?
Yeah.
Okay. Now, next question says a student thought that buta-1,3-diene can show stereoisomerism. The student drew out skeletal formula for the stereoisomers of butane-1,3-diene. Explain the term stereoisomerism. It's same structural formula, but they have different arrangement of atoms in space.
Isn't it same molecular formula?
No, they have the structural formula as well.
Oh, okay.
Can be both same molecule and same structure, they just have different arrangement in 3D space.
A different arrangement in space. Make sure you say of atoms slash groups. Now, there's a condition that needs to be satisfied here as well. What is that condition? You must have two different atoms or groups on the carbon atom bonded across the double bond. So in this case, is explain with the reason whether the student is correct or incorrect. So he is incorrect in this case. Why? Because look here at this location, this carbon will have two hydrogens. This carbon will have two hydrogens. So if it has two hydrogens, you can't have, right? So we can say two groups on one C atom in C double bond C are same. Done. Move on to the last bit. Now this is the part that I didn't really like, but it just gives you a bit of information. So sometimes you'll have to assess the situation to work out the answer. What is happening is they're saying if you have something like this, then it will change into this. It will change into. So how does that happen in this case? They've told us something here, and what is that thing here? You can see this bond is due to this section. Does that make sense? Okay, so I can then say similarly this bond will move here and this will then appear here. Agreed? For this to be formed double bond, I'll say this will then move. Are people with me on this bit? So you'll have to assess the situation. You can see here, they said if you combine this with this, it will change. They are giving you a little bit of information here. So this double bond will change into single bond. One of this bond will move here and appears here. There's a double bond here, it will move forward and will appear here. For this to change into double bond, two electrons have to be moved at this location. Now the next bit, a little bit different. What is happening here is it says there are two more reactions and they're shown below. So draw the organic product of each reaction. What will happen in this case? We just have to assess the same situation. Look, you've been given a double bond. What will happen to this double bond? This will move to this location. Agreed? This will move to this location, and this will move to this location. So if I look at it, basically this section will change into this form, and then the remaining will be the same. I can draw it out and I can say 2 each OCH3 OCH3 double bond O double bond O this location. Okay, and 1 2 did people understand what I did here? It took me a while to figure it out myself. I can't blame you guys, right? Next part here, this is important to understand this section. In this case, you have how many carbons do you have? This is equivalent to, is the same as C dash C double bond C dash C. Okay, this is same as that. So you have to make sure you understand this bit. So exactly same thing will happen like it happened above. So I can say one of this will move at this location. This one will move at this location. This one will move at this location. But this time what will happen? There was a triple bond here. So double bond will remain here. Double bond will remain here. So I can then say it will change into this section here. But you will also have a double bond at this location, and I need to add two more carbons, 1 and 2. This one and this one are the same. This one and yeah, and this one are the same. Okay. Now let's move on to the multiple choice questions. From the multiple choice questions, stars on some of these. Can I please ask you to do question number 11 and 12? Question 11 and 12, please. Let's quickly have a look at these two questions then. What we have here is the moment I see this is for OH. This is for C double bond O. Okay, now this is alcohol. This C double bond O, this means this is carbonyl compound. Now, it can't be this because it doesn't contain OH. It can't be this because it doesn't contain alcohol. Now I'm left with only two options. This one has OH, but it has no carbonyl. So the answer will be D in this case. Because it contains, look, it contains carbonyl compound, it contains alcohol groups. This is both of them are present, and that's my answer. Next question, question number 12 says which peak would be in the mass spectrum of propanol, which is this, but not in the mass spectrum of propanone. So what I did is I worked out their MRs first. Yes, Ridwan, go ahead.
So for the first one, when it's OH, I thought the carboxylic one was the broad one of the alcohol.
This no. Now you were not with me last year. Carboxylic acid has something like that.
So it's like multiple.
Yes,
Or like,
but the alcohol one looks like that.
okay.
Okay. Question number 12 says which peak would be in the same which would be in the mass spectrum of propanol but not in spectrum of propanone. I can see they both have same MR, so this will be there. It will be present. How about 15? Yes, if I break it from here, if I break it here, this will also be present. Okay, how about 29? Work out, see what is 29 and what is 43.
29 is only in the first one.
29 is only in the first one because to, what is this equivalent to?
It's the C double bond OH.
Is it C double bond?
OH.
How is it C double bond OH?
No, that's just like that's C double bond. Oh, I mean just C double bond O and then H.
Okay, this section. That's fine. So the answer is B. So we have done. Okay, let's start from the first question and then we can finish it off. The first question says 2-methyl butane is reacted with chlorine by radical substitution. What is the number of structural isomers with molecular formula this that could be formed? Look, what was your starting material? 2-methyl butane. So if I draw it, it's going to be 1, 2, 3, 4. At this location, you have carbon. So we can have chlorine at this location, at this location. We can have at this location, at this location, and at this location. But out of this, I can see this one and this one are the same. This one and that one are the same. So if they are both same, this is number option 2, option 3, and option 4. So in this case, in total, I can have the 4 different structural isomers. Are we happy? Next question. Which types of stereoisomers are shown by 2,4-dimethyl hex-2-ene? Hex-2-ene will be where? I can say 1, 2, 3, 4, 5, 6. At location number 2, you have this. But it says on the second carbon and on the fourth carbon, you have CH3, 1, 2, 3, and on the fourth one, CH3. Now, if you look at it, you've got CH3 here, you've got CH3 here. No E and Z is possible. No E and Z possible. But if I look at it carefully, this is my carbon carbon because above it is CH3, below it is hydrogen, on the right it is C2H5, on the left I have something else, so it will be only optical isomers. Next question says which sample contains greatest number of carbon atoms? Now this is one marker. I would not answer this question at all in exam. Yes, if I have time towards the end, I'll do it. But because it involved a lot of working, right? So what I had to work out the MR for all of them. Okay, once I worked out the MR, I'll have to do mass of carbon divided by MR times by given mass. And that will determine the amount, which one will have the maximum amount of carbon. I never did it right. I did it, but I don't know where I put that page. I wrote all the values on it, but I can't. I can give you the answer for this one is C. Was around 21%, something like that. Next question. This question is about incomplete combustion of butane 1-ol. So incomplete combustion means it should produce CO plus H2O. Now, if I look at it, this is not possible, this is not possible. So there are only 2 options possible, this and this, they're both fine. But I now need to work out, are my oxygens balanced? If you look, there are 4, add 5, 9 oxygens here. You've got 9 and 1, 10 oxygens here. So this is not the right one. This is correct. This is wrong. So the answer is C. Next question says 2-methyl cyclopentanone shown below is reacted with sodium cyanide to form an organic product. So when you react it with sodium cyanide, what will happen? It will then change into then change into OH, and here you will have CN. So the answer here, it says in the mechanism a cyanide ion accepts an electron pair. Can it accept electron pair? This is wrong because it already has got surplus electrons. The mechanism is electrophilic addition. Is electrophilic addition. It's not, because cyanide is nucleophile, so it is again wrong. The organic product has one chiral carbon, has got one chiral carbon. Let's see. At this location, got this molecule, below is something else, above is something else. So this is my one chiral carbon. This is also my chiral carbon, so it has two chiral carbons. So for question number 5, the answer would be wrong. It has two. The answer is D. And if you check it, you will figure it out as well, because 1, 2, 3, 4, 5, 6. How many carbons do I have? And then 7. This is correct. Next question. Says you've been given this. This is my ester. It is heated with aqueous sodium hydroxide. So you're using alkaline conditions. So when you use alkaline conditions, what happens in this case is it will produce alcohol plus carboxylic acid. But this will react with NaOH and it will change into salt. So your final products will be these two. That's what it says. So what's going to happen in this case? You've got alcohol, and this is wrong. In this case, you have alcohol and you have been given a salt. So the answer is B. Okay, answer is B. This is wrong here. This is wrong as well. In this case, they are both right. This is right. This is wrong here. This is right. In this case, this is correct. This is wrong. Question number 8. So on question number 8, we've been given bond angle of this. This means you need to have something like this, which contains this. Not in A, not in B, but C does contain this kind of thing, right? This location. So C has it. Question number 9. Which reaction is not a reduction reaction? Okay. Where's this one? This is substitution reaction.
So what was the answer?
Question
Question 7.
7, A. Question 7 was A. On this question, it says you have to work out the RF value. What is RF value? This is distance traveled by sample over distance traveled by solvent from. Okay. So in this case, what will happen in this case, you can see here, you'll have to measure this distance, this is, and you'll have to measure this distance. I'm going to call it D, and I'm going to call it D. So you'll do D over D1, and if you do that, you'll end up with answer being A. And it looks like this is 25% off this. Okay. Let's turn it over. Question number 14 says, which of the following statement provides evidence for the delocalized model of benzene rather than the Kekule model? The enthalpy change of hydrogenation is more exothermic. Is it more exothermic? This is wrong. It is more, it is less exothermic. Benzene only reacts with bromine in the presence of halogen carrier. That's right. The carbon-carbon bond angles all have same length. That's true as well. So 14, the answer is C. And we already did question number 15 at the start. Now,
So what was question 13?
question 13B. Now, what I'll do is